Okay, students, today I will discuss the electric field intensity due to the charged sphere. Sphere, hollow sphere, or charged solid sphere, conducting or non conducting solid sphere. One by one, I will discuss. Okay, all of you, students, please give the heading. Students, please give the heading. The electric field charged sphere. Electric field, all of you give the heading, students. Electric field, electric field due to the charged sphere, due to the charged sphere. This is the topic. ठीक है ना? But sphere, there are two types of sphere. ठीक है ना? एक तो hollow, एक hollow sphere, and another is solid sphere. This is solid. Hollow sphere, there are two types. Number one, conducting sphere. Conducting sphere, and number two is non-conducting. ठीक नो? Non-conducting sphere. Non-conducting मतलब insulated. Non-conducting is insulated or dielectric. Insulated or dielectric. ठीक है ना? Dielectric. And conducting sphere मतलब metallic sphere. ठीक है ना? And solid sphere also, there are two types. Number one, conducting, like this. Conducting and non-conducting, same thing. Non-conducting. ठीक है ना? So classification I have told this one. Hollow sphere and solid sphere, one by one, and all spheres are charged. One by one we will find the electric field intensity. So first see hollow sphere, charged hollow sphere. All of you give the heading electric field intensity due to the hollow sphere. Electric field E. E for hollow sphere. Electric field for hollow sphere. Take no? Hollow sphere. Okay, now see here. Hollow sphere like this. देखो. This is the hollow sphere. Hollow मतलब अंदर खोखला. Inside, hollow means inside no material. Only outside material is there. ठीक है ना? This is hollow. This is hollow sphere. Okay. This is hollow sphere. Charged hollow sphere. So now see, charged hollow sphere matlab for the hollow, charge always resides on the surface of the sphere. This is the charge. ठीक no? Charged hollow sphere. Charged hollow sphere. This is the center of the sphere. It is hollow. No material inside this. So first write, for the hollow sphere, for the hollow sphere, all of you write, the charge resides always, resides on the surface on the surface of the spheres. On the surface of the spheres. Charge अंदर में नहीं है. Charge always will reside on the surface of the sphere. This is the hollow. ठीक है ना? This is the hollow sphere. Charge outer side में, outer surface में. ठीक है ना? तो assume amount of charge is plus q. Plus q charge resides on the surface of the sphere. But here there are three cases we have to discuss one by one. Okay, that portion I am erasing this one. ठीक है ना? तो इलेक्ट्रिक फील्ड ड्यू टू द हॉलो स्फीयर, डिस्टेंस वी हैव टू टेक. फर्स्ट कंडीशन इज, नंबर वन कंडीशन, आर लेस देन आर. आर लेस देन आर मीन्स this is the radius of the hollow sphere, and r less than capital R means the point remains inside the sphere at any point P inside the sphere at a distance r from the center. At this point what will be the electric field? ठीक है ना? At this point what will be the electric field? So I have told in previous classes at which point we have to find the electric field intensity. At that point we have to draw, taking the distance r, we have to draw the hypothetical surface, that is the imaginary surface, that is called the Gaussian surface. At this place draw the Gaussian surface. This is the Gaussian surface. Okay. So very small Gaussian surface ds vector, and Gaussian surface direction in this direction, this is the direction of the area vector ds vector, and also assume this is the electric field direction, ठीक है ना, in this direction. Am I clear? But according to Gauss law we can write here electric flux phi is equal to surface integral E vector dot ds vector is equal to q in divided by epsilon naught. It is Gauss law, Gauss theorem. It is Gauss's law. Okay. This is Gauss's law, Gauss theorem or Gauss law. Electric flux phi मतलब electric flux phi is equal to surface integral of electric field E vector dot ds vector is equal to q inside divided by epsilon naught. Q in मतलब total charge enclosed by the surface. Enclosed by the surface means charge enclosed by this Gaussian surface. But now see, it is hollow. Inside the surface electric field is 0. Here electric field is 0. Here electric field is 0. Inside no electric field 0. Why? Now inside this q 0, no charge. Q in is equal to 0, then electric field will be 0. How? Dekho. Now see, we can write here surface integral, just break this, E into ds cos theta means cos 0 degree, same direction, area direction of the area vector and electric field theta 0 degree, and then we can write here q in divided by epsilon naught according to Gauss theorem. Cos 0 1 E into surface integral ds is equal to q in, we can write according to Gauss law. So now see here ds integration s, E into s, ds integration s, then q in divided by epsilon naught. S means area of the hypothetical surface, Gaussian surface, area of the Gaussian surface, area of the Gaussian surface S. Here area of the Gaussian surface S is equal to 4 pi r square. So now we can write here E into 4 pi r square is equal to q in divided by epsilon naught. And already I have told q in is 0 because it is hollow. Inside there is no charge, no existence of the charge. So instead of q in we can write here 0 divided by epsilon naught is equal to 0. Then from this relation also we can write here 0 divided by 4 pi r square, then it will be 0. Therefore inside electric field E in is equal to 0. So for the hollow sphere r less than r, for this condition, number one condition r less than r, electric field is 0. Have you understood? With the help of Gauss theorem. So also we can write here on the surface. On the surface, what will be the electric field? Now on the surface, just take the distance radius r. From this radius r, so here electric field, what will be this electric field? On the surface electric field, what will be this electric field? Because here charge resides on the surface. Clear? So here electric field, number 2 case, R is equal to R. ठीक नो? R is equal to R, इलेक्ट्रिक फील्ड का वैल्यू E is equal to KQ divided by R square. ठीक नो? ये हो जाएगा. On the surface E is equal to KQ by R square. Again with the help of the Gauss law, we can assume here very small surface. Assume करो. यहाँ पे distance. This is the direction of the area vector ds vector. This is the electric field vector direction. Angle between this 0 degree. फिर apply करो Gauss theorem. We will get on the surface of the sphere R is equal to R KQ by R square. E is equal to KQ divided by R square. This is the electric field on the surface. R is equal to R matlab on the surface of sphere, of hollow sphere. Of hollow sphere. Clear? Number 3 case. Number 3 case C. R greater than R. R greater than R means greater than radius of the sphere. Now we have to assume the point outside of the sphere. Point outside of the sphere. Diagram will be like this. Again I am drawing this diagram. Now see, for this condition, this is the sphere. Okay, this is the sphere. So outside take any point P. From this R point, from the center distance R, and this radius is R, and from the center at P point we have to find this electric field. So at which point, again I am telling, at which point we have to find the electric field intensity. Taking that point, describe the hypothetical surface, Gaussian surface draw. Okay. So now taking this distance, I am drawing one Gaussian surface. This is the Gaussian surface I am drawing here. Okay. Assume this is the Gaussian surface. Clear? Taking that point, I have drawn the Gaussian surface. After drawing the Gaussian surface, assume one small area. Assume one small area. Assume this is the small element area, and this area vector direction in this direction ds vector, and also the electric field direction in this direction theta is equal to 0 degree. Angle between ds and E, and here the charged hollow sphere. Charge always resides on the surface of the sphere. Clear? Now we will apply Gauss theorem again. Again we will apply Gauss theorem. What will be the Gauss theorem? So now we apply the Gauss theorem. Surface integral electric flux E vector dot ds vector is equal to Q in divided by epsilon naught. Q in enclosed the surface. Take na? So Q enclosed, actually under of this Gaussian surface, inside this Gaussian surface, what is the charge? Dekho. Charge of the sphere was what? Charge of the hollow sphere was plus Q. So Q in, instead of, in the place of the Q in, we can write here Q. Then we can write here integration break E dot ds, matlab E ds cos 0 degree is equal to Q by epsilon naught. Okay, cos 0 1 E into ds, ds integration s, E constant out of integration, and into s, ds integration s is equal to Q by epsilon naught. Enclose the surface charge Q. S means area of the Gaussian surface. What will be the area? Spherical surface. This Gaussian surface is spherical in nature. Okay. Any problem to understand? Spherical nature, taking the distance, taking this distance r, area S is equal to 4 pi r square, small r square. Then we can write here, instead of S, E into 4 pi r square is equal to Q divided by epsilon naught. Now E is equal to, it will be 1 by 4 pi epsilon naught Q divided by r square. Now see, just we have got electric field due to the point charge. This formula has come like as the point charge, electric field E is equal to 1 by 4 pi epsilon naught Q by r square. But one thing we have to see, now see here, for the r less than r, for this condition, electric field is what? 0. And for r is equal to r, electric field kya? Number 2 condition was electric field E is equal to K matlab 1 by 4 pi epsilon naught into Q by r square. Here Q means small r. 1 by 4 pi epsilon naught Q by r, capital R. Okay, no? Condition is r is equal to r. Now see here Q and here capital R. It is Q into capital R. Any problem to understand, students? And third case we have got electric field E is equal to 1 by 4 pi epsilon naught like as the point charge Q by r square. But taking these values, if you draw the graph, electric field versus distance, will take the nature of the graph. Nature of the graph will be like this. Okay, I am erasing this portion. In this portion, I will draw the electric field versus distance. Okay, now see here. Now see, in this portion I am erasing. Students, I think you have copied. Okay, now see here. Just draw the x-axis and y-axis. First draw the hollow sphere, this position. Okay, this is the hollow sphere. Now see here, one x-axis and y-axis. This is y-axis. This is y-axis, and assume this is x-axis. Clear? So now see, it is the center of the sphere and it is the hollow charged sphere. Okay, hollow charged sphere. And amount of charge we had assumed plus Q. Amount of charge we had assumed plus Q, charge always resides on the surface. And we have seen at the center or at any point inside, electric field was what? 0. And this is the radius up to this region. Distance r is equal to r. It will be equal to the radius. So up to this region, into this region, no electric field exists. No electric field exists into this region. In this region, electric field is 0. Am I clear? But after the surface, electric field we are getting, it is acting like this. Right now, E is equal to electric field KQ by r square. ठीक है ना, r square. So just for this relation, we are saying electric field is inversely proportional to the square of the distance. Square of the distance means like as the rectangular hyperbola. But this graph will not touch at any point on the x-axis. Why? Now, if this graph touches on the x-axis at a particular distance, electric field will be 0. But practically not possible. Electric field can be existed up to infinite distance. That's why this graph will not touch on the x-axis. That's why this graph will not touch on the x-axis. Just graph will be like as the rectangular hyperbola. Like this. So here electric field is inversely proportional to the s square of the distance. This is the nature of the graph for the hollow sphere. This is y-axis and this is x-axis. Clear? So this is the graph. Electric field versus R. for the hollow sphere, for the hollow sphere, okay, for the hollow sphere, clear? But it is the conducting sphere we have taken, and also you can take the non-conducting hollow sphere, so everything will be same. And for the solid sphere also conducting and non-conducting. For the solid sphere, conducting solid sphere means charge always will remain outside. For the non-conducting solid sphere means charge remains at every point. That we have to take the volume charge density. Through whole metal, through all places, through all points, the charge will be existed for the non-conducting solid sphere. Clear? So now see here. Just now we will see, students please copy this. Next point we will go, that is the electric field intensity due to the charged non-conducting solid sphere. That is the important for the Cbse. One by one discuss like this: inside the solid sphere, on the surface of the solid sphere, outside of the solid sphere, and finally we will draw the graph. Okay. Can I go to the next page, students? Okay, I am going to the next page. Now see here, students. All of you give the heading electric field intensity, electric field intensity, electric field intensity due to the charge, due to the charged non-conducting solid sphere, non-conducting solid sphere. This is the thing. Okay, non-conducting solid, solid मतलब अंदर में material है, inside the sphere material is there. I am drawing here, first I am drawing the solid sphere, non-conducting. Non-conducting means like as insulating material, like as the dielectric material, like that. Okay. Now see, here assume this is the solid sphere, non-conducting. Okay. Here charge remains at every place. Charge remains here at every place. Clear? At every place, at every point charge resides, not only on the surface. At every point positive charge remains. Clear? Okay, all of you draw with me. Positive charge. ठीक ना? A positive charge. Positively charged non-conducting solid sphere. Okay, at every place. Surface में है, inside the sphere, like this. Okay, this is the charged. So first we will find the electric field intensity inside the solid sphere. This is the radius of the sphere, capital R. Number one point see here, amount of charge assume karo plus Q. Clear? Plus Q means charge of the solid sphere. Charge of the solid sphere. Number one point is electric field when distance R less than R, means inside the sphere. In bracket I am writing also inside the sphere, ठीक ना, inside the sphere. So what will be the electric field? C. But for the solid sphere charge remains at every point, but here we have to consider the volume charge density. Volume charge density, all of you write with me, rho is equal to volume charge density rho. Volume charge density means charge per unit volume. Here for the volume is 4 by 3 pi r cube. Volume. It is the volume of the solid sphere. Right? In unit volume, 4 by 3 pi r cube. In this volume total charge Q. In unit volume charge Q by 3, 4 by 3 pi r cube. This is the rho. It is the volume charge density. Coulomb per meter cube. Okay. Rho value is q divided by 4 by 3 pi into r cube. Volume charge density coulomb per meter cube. But we are going to find the electric field intensity here. R less than R. Assume at P point we are going to find the electric field intensity. What have I told? What have I told? I have told many times at which point we have to find the electric field intensity. Taking that point, draw the Gaussian surface. So taking that point, just to draw one Gaussian surface, taking the radius is small r. This is the Gaussian surface is small r. Again, like before, here we have to draw one small area direction in this direction ds vector, and also the electric field direction E vector. Here angle between E and ds theta is equal to 0 degree. Clear? Any problem to understand? Any problem to understand, students? Okay. Now see here. Now see, just this distance is r vector. Okay. This distance is r vector, is area vector, this one, ds vector, this one, and electric field, this one, electric field E vector, this one. Clear? And this is the center O. Okay. Gaussian surface we have drawn. According to Gauss theorem, electric flux E vector dot ds vector is equal to q inside divided by epsilon naught. Clear? And break the dot product, we can write here E into ds cos 0 degree is equal to q in epsilon 0. Here E outside of the integration cos 0 1 into integration ds is equal to q in divided by epsilon naught. But here ds integration into s is equal to q in divided by epsilon 0. Am I clear? S means surface area. Whose surface area? S means surface area of the Gaussian surface. Surface area of the Gaussian surface. Area of this surface. Area of this surface. Spherical surface. So what will be the area of this surface? Tell me. Area of the Gaussian surface. Area of Gaussian. Area of the Gaussian surface. Area of Gaussian surface is E is equal to A is equal to 4 pi r square. Okay, is 4 pi into small r square. Why? Now radius is r. Instead of s, we can write here E into 4 pi r square is equal to q in divided by epsilon naught. Then we can write E is equal to q in divided by 4 pi r square into epsilon naught. This is the electric field. But q in what? Dekho. Please see here. Charge for the total volume. Charge for the total volume q in unit volume charge this one. So the volume of the Gaussian surface what? Volume of the Gaussian surface is 4 by 3 pi r cube. So in this volume what will be the charge? Assume karo q dash, and it will be multiplied by rho per unit volume charge, that is 4 by 3 pi r cube into rho. Then we can write 4 by 3 pi r cube into here, instead of q a rho, q 4 by 3 pi into capital R cube, 4 pi by 3, 4 pi by 3. Then we can write here q into r cube by capital R cube. Clear? That is the charge inside q in, q dust. Here q dust is means q enclosed, q in. So instead of q in, we can write here what is the charge? Now q into r cube divided by r cube into 1 by 4 pi r square into epsilon naught. Here see, r square, 1 r square, just 1 into r. Here 1 by 4 pi epsilon naught. Finally, we are getting 1 by 4 pi epsilon naught q into r divided by r cube. This is the electric field intensity inside the solid sphere. K, or 1 by 4 pi epsilon naught total charge into that distance divided by radius of that cube, r cube. Okay. For the number 1 case, we have got this relation. It is important for solution of the numerical inside of the solid sphere. Electric field E is equal to K into total charge. At which distance we have to find the electric field? That distance divided by radius of the sphere. And K का जगह पर K is equal to 1 by 4 pi epsilon naught. Okay. Am I clear? So this is the electric field for the case number 1. Am I clear? This is the electric field for the case number 1. Similarly, case number 2, now see here, case number 2, electric field E at R is equal to R. Means at which point we have to find the electric field intensity? R is equal to R means that distance was R, small r. R is equal to R. R means capital R means on the surface. So R is equal to R means the electric field intensity on the surface of the sphere. So in this equation also you can write here R is equal to R. No need to derive this. But when the question will come in for the Cbse board, you have to derive, because for the Cbse board derivation is important. For each line mark is allotted here. Okay. Now see here. So similarly we can write here the electric field intensity on the surface of the sphere, electric field E, just put the value R is equal to R. Now see here, electric field equation, E is equal to KQ R. Instead of small r, just put here capital R. Then we can write here, R cube, R will be cancelled to R square. Finally, we are getting KQ by R square. And instead of K, put here the value 1 by 4 pi epsilon naught, here Q by R square. Okay. Just electric field like as the point charge, it has come on the surface of the sphere. That formula like as the point charge electric field. So we can't say on the surface of the sphere, electric field intensity, this one. Have you understood, students? Any problem? Any problem, students? This is the electric field intensity due to the non-conducting charge solid sphere on the surface. Okay. I think you have understood. Have you copied the students? Any dikkat? Any problem? Okay. Last case, see here. So now see here, for the first condition, we have got here, electric field Q or 4 pi epsilon R cube. For this relation, electric field directly proportional to the distance. Inside the solid sphere, what is the relation between electric field and the distance? Directly proportional. But in this case, we are seeing electric field is inversely proportional to the square distance. For this relation, two relations we have got. Up to this, any problem to understand? Can I go to the next page? No? Okay, I am going to the next page. Now see here third case. Now see, again I am drawing the charged non-conducting solid sphere like before. Okay. Now see, it is the radius. Beyond of radius, assume at P point. At this point, we have to find the electric field intensity at a distance R from the center. And radius of the sphere is capital R. Clear? And here charge remains here, not hollow. A solid sphere. At every point charge remains, I have told in previous time. Right now, plus charge remains here. Okay? Plus charge remains. Clear? But point beyond of the radius. And again I am telling at which point we have to find the electric field intensity. At that point, taking that point, draw the Gaussian surface first. Take no? So at this point, we have to find the electric field intensity. Taking that distance r, small r, this distance is small r. Taking that distance, just to draw the one Gaussian surface. One Gaussian surface. Draw the one Gaussian surface. Draw. This is the Gaussian surface I have drawn here. Right? No? This is the Gaussian surface. Spherical in nature Gaussian surface. Any problem to understand? Okay. Dekho, this is the Gaussian surface. Okay. Gaussian surface. Like before, at this point just assume very small element, area element, assume ds vector. Area is not the vector quantity, but small vector will be treated as the vector quantity in some situations and in some problems for the physics. So that is the area, direction of the area vector in this direction, ds vector, area vector direction. And assume the electric field direction in this direction, electric field direction. Like before, angle between electric field and ds vector, theta is equal to 0. 0 degree means angle between E vector and ds vector is equal to 0 degree. Any problem? So again we can apply Gauss law. Applying Gauss law. Now see here. Applying Gauss's law, just you will write like this. You will drive like this in for the Cbse board. Applying Gauss law, we can write electric flux phi E is equal to surface integral E vector dot ds vector q enclosed divided by epsilon naught. Q in means charge enclosed by the surface, enclosed by the Gaussian surface charge. At this point, charge was what? For the solid sphere, total charge we had assumed, I had assumed Q charge. Am I clear? Any problem to understand, students? Okay. So break the dot product here. Now see, देखो, E into ds cos 0 degree is equal to Q. Q in means total charge. Q in Q we have taken Q epsilon naught, cos 0 degree 1. And here E out of integration only dx is equal to Q divided by epsilon naught, and ds integration s, E into s is equal to Q by epsilon 0. This portion I am writing in this direction. That equation I am writing again here. Okay, students? Now see here. Here S means area. Whose area? Area of the Gaussian surface. S means area, surface area. Whose surface area? Area of the Gaussian surface. At Gaussian surface radius is small r. So area of the Gaussian surface is spherical in nature. The area of the Gaussian surface, it will be 4 pi r square. Area. This is A. A means area of the Gaussian surface. Clear, no? Then we can write here area 4 pi r square and total charge Q by epsilon 0 or not. Now see here, electric field E is equal to, we can write in next line 4 pi r square into epsilon 0. So just rearrange it, rearranging right here 1 by 4 pi epsilon naught Q by r square. Take this constant K, KQ by r square. It is the electric field. So now see, outside of the solid sphere, now see, electric field outside of the solid sphere we are getting like as the electric field for the point charge. And for this relation, also I am writing here, it is also the electric field, it is also electric field like as point charge, like as point charge, like a single charge, single point charge. Okay, right? So from this relation we can say electric field is inversely proportional to the a square distance. Means with respect to the distance, electric field will be started to decrease, rapidly will be started to decrease. Right now? Am I clear? Again I am telling, now see, again I am telling, at inside electric field relation was what? Directly proportional. Clear? Up to what? Up to surface. Outside electric field inversely proportional to the a square distance. Okay, right now? Up to surface it is constant. So what will be the graph? Okay, students, first copy this one. Finally, we will draw the diagram electric field versus distance graph. Okay? Okay, students, have you copied this region? No? This portion have you copied? I think you have copied this one. I am erasing this portion. Okay, now see here. Now see, here say students, just draw the solid sphere. Assume this is the solid sphere. Okay, this is the solid sphere. Clear? Now see, draw one x-axis and y-axis. Assume this is x-axis, a y-axis, okay, and this is x-axis. Clear? Now see, this is origin O and this is y-axis, and this is radius. Up to this, just draw this line. Here r is equal to r. Distance, radius का साथ बराबर. The radius is equal to the distance is equal to the radius. So now see, up to radius, electric field is directly proportional to the distance. For the directly proportional electric field, what? Like this straight line. Am I clear? Have you understood? A straight line. But after the surface, it will be started to the hyperbolic in nature because E varies 1 by r square. So for this graph, electric field is directly proportional to the r, and after the surface S, electric field is inversely proportional to the distance, a square of the distance, C varies r square. It is the rectangular hyperbola. This is the nature of the graph for the charged non-conducting solid sphere for the case of the electric field versus distance. Okay, students. So in next class, also we will derive electric field for many things, and also we will solve the different kinds of numericals. Students, today up to this, all the best. Study with rapt attention. Thank you, students.